When dealing with pouring seal-offs in freezing conditions, several strategies and product options can be considered. Firstly, investigate the use of Zypixit Mix -11, a concrete waterproofing admixture designed for use in below freezing temperatures, specifically down to -18 degrees Celsius or 0 degrees Fahrenheit. Secondly, explore Penetron crystalline waterproofing, a crystalline waterproofing compound that can be added to concrete mixtures even when working below freezing. Thirdly, consider Master Seal P450, an epoxy-based sealant suitable for use in temperatures as low as -18 degrees Celsius or 0 degrees Fahrenheit. It is crucial to understand that mixing seal-offs with RV antifreeze is generally not a recommended practice. RV antifreeze is formulated to prevent the freezing of water systems and contains solvents that may interfere with the proper curing process of the seal-off material. Once the seal-offs are poured, implement measures to cover and protect them from direct exposure to freezing temperatures for as long as practically possible. This insulation can help to retain heat and promote curing. Employ a temperature monitoring device to closely track the temperature around the seal-offs, ensuring that it remains above freezing for a minimum duration of 8 hours, which is the typical curing time requirement for most seal-off products. Explore the use of portable heaters or warming blankets to effectively raise the temperature in the immediate vicinity of the seal-offs, thereby preventing them from freezing during the critical curing phase. It is strongly recommended to directly consult the manufacturer of the specific seal-off products being used. They can provide detailed instructions and tailored recommendations for installations performed in below freezing conditions, taking into account the specific properties of their product. Proper planning, combined with the appropriate materials and techniques, is essential to ensure the successful installation of seal-offs in challenging, cold weather environments. The curing time of seal-offs is crucial for their performance. If the seal-off does not cure properly, it may not provide the necessary protection against explosion or fire. Therefore, it is important to take steps to ensure that the seal-offs are kept above freezing for at least 8 hours after they are poured. If you are working in an area where the temperature is consistently below freezing, you may need to take additional steps to protect the seal-offs. This may include using a heated enclosure or wrapping the seal-offs in insulation. It is also important to monitor the temperature of the seal-offs regularly to ensure that they are not getting too cold. If the seal-offs do freeze, they may need to be replaced. Therefore, it is important to take precautions to prevent them from freezing in the first place. When working with seal-offs in cold weather, it is also important to wear appropriate personal protective equipment such as gloves and a hat. This will help to protect you from the cold and from any potential hazards associated with the seal-off material. In addition to the products mentioned above, there are a number of other products that can be used for pouring seal-offs below freezing. These include heated seal-off compounds and seal-off blankets. Heated seal-off compounds are designed to be heated before they are poured, which helps to ensure that they cure properly even in cold weather. Seal-off blankets are used to insulate the seal-offs after they are poured, which helps to keep them warm and prevent them from freezing. When choosing a product for pouring seal-offs below freezing, it is important to consider the specific conditions of the job site. Factors to consider include the temperature, the wind speed, and the humidity. It is also important to consider the type of seal-off material that is being used. Some seal-off materials are more resistant to cold weather than others. Once you have considered these factors, you can choose the product that is best suited for the job. When pouring seal-offs in cold weather, it is also important to follow all safety precautions. This includes wearing appropriate personal protective equipment and following the manufacturer's instructions for the product being used. By following these precautions, you can help to ensure that the seal-offs are installed safely and effectively. Seal-offs are used in hazardous locations to prevent the passage of gases, vapors, or flames from one portion of the electrical system to another. They are typically installed in conduit runs that pass from a hazardous location to a non-hazardous location or between two hazardous locations. Seal-offs are filled with a sealing compound that is designed to create a gas-tight and flame-tight seal. The sealing compound must be compatible with the type of hazardous material that is present in a location. There are two main types of seal-offs, those for vertical and horizontal applications. The type of seal-off that is used will depend on the orientation of the conduit run. Seal-offs must be installed in accordance with the National Electrical Code, or NEC. The NEC specifies the types of seal-offs that are permitted in different hazardous locations, as well as the installation requirements for seal-offs. The NEC also specifies the types of sealing compounds that are permitted for use in seal-offs. Seal-offs are an important part of the electrical safety system in hazardous locations. By preventing the passage of gases, vapors, or flames, seal-offs help to protect people and property from explosions and fires. The selection of a seal-off for a specific installation should take into account several factors. Firstly, verify that the seal-off is specifically listed and labeled for use in the particular hazardous location. This ensures compliance with safety standards. Secondly, confirm that the seal-off is compatible with the specific type of conduit being used, whether it is rigid metal conduit, or RMC, intermediate metal conduit, or IMC, or another approved type. Thirdly, select a seal-off of the appropriate size for the conduit diameter to ensure a proper seal. Fourthly, choose a sealing compound that is compatible with the environmental conditions, including temperature extremes and exposure to chemicals that may be present. The installation process for seal-offs requires careful attention to detail. Firstly, thoroughly clean the interior of the seal-off and the conduit ends to remove any debris or contaminants that could compromise the seal. Secondly, properly mix the sealing compound according to the manufacturer's instructions to achieve the correct consistency and curing properties. Thirdly, carefully pour the sealing compound into the seal-off, ensuring that it completely fills the void and encapsulates the conductors. Fourthly, allow the sealing compound to cure fully according to the manufacturer's recommendations before energizing the circuit. Regular inspection and maintenance of seal-offs are essential to ensure their continued effectiveness. Firstly, periodically inspect seal-offs for any signs of damage, such as cracks, corrosion, or leaks. Secondly, verify that the sealing compound is still intact and has not deteriorated over time. Thirdly, if any damage or deterioration is detected, promptly repair or replace the seal-off and sealing compound to maintain the integrity of the electrical system. The NEC provides specific guidelines regarding the location of seal-offs in hazardous locations. For example, NEC Section 501.15 addresses sealing requirements in Class I, Division 1 and 2 locations. It specifies the distances from enclosures where seal-offs must be installed to prevent the propagation of explosions. NEC Section 502.15 covers sealing requirements in Class Roman II, Division 1 and 2 locations, addressing the hazards associated with combustible dusts. NEC Section 505.16 provides requirements for sealing in Zone 0, 1, and 2 locations, which are based on the IEC system of hazardous area classification. Understanding these NEC requirements is crucial for ensuring compliance and safety in hazardous locations. Additional considerations for seal-off installations in cold weather include firstly the use of heat trace cable to warm the conduit and seal off before pouring the compound. This can help to ensure that the compound flows properly and cures evenly. Secondly, insulating the seal-off after pouring the compound. This will help to retain heat and prevent the compound from freezing. Thirdly, monitoring the temperature of the seal-off during the curing process. This will help to ensure that the compound cures properly and that the seal-off is effective. Safety is paramount when working with seal-offs in hazardous locations. Firstly, always to energize the circuit before working on any electrical equipment. Secondly, wear appropriate personal protective equipment, or PPE, including safety glasses, gloves, and a respirator if necessary. Thirdly, follow all manufacturers' instructions and safety guidelines when installing and maintaining seal-offs. Fourthly, be aware of the potential hazards in the area, such as flammable gases or combustible dusts. Fifthly, have a fire extinguisher readily available in case of an emergency. By following these safety precautions, you can help to protect yourself and others from injury. Seal-offs play a critical role in maintaining electrical safety in hazardous locations. They are essential for preventing the spread of explosions and fires, and for protecting people and property from harm. By understanding the selection, installation, and maintenance requirements for seal-offs, you can help to ensure that your electrical system is safe and compliant. The specific type of hazardous location dictates the necessary requirements for seal-offs. For instance, Class I locations involve flammable gases or vapors, requiring seal-offs to prevent the passage of these substances. Class Roman II locations deal with combustible dusts, mandating seal-offs to prevent dust accumulation and potential explosions. Class Roman III locations involve ignitable fibers or flyings, necessitating seal-offs to prevent these materials from entering electrical enclosures. Each class has divisions indicating a likelihood of hazardous material presence, influencing seal-off requirements. Division 1 signifies a high probability of hazardous material presence under normal operating conditions. Division 2 indicates a lower probability, with hazardous materials present only under abnormal conditions. Zones used in IEC systems further refine hazardous area classification. Zone 0 represents continuous presence of hazardous materials. Zone 1 indicates likely presence during normal operation. Zone 2 signifies infrequent presence. Seal-off placement is critical for effectiveness. Seal-offs should be placed as close as practical to the enclosure they protect, typically within 18 inches or 45.72 centimeters to minimize explosion propagation. They must also be installed where conduit enters or leaves a hazardous area, preventing the spread of hazardous materials. Vertical and horizontal conduit runs require specific seal-off types. Vertical seal-offs have a dam or internal structure to prevent sealing compound from running out during pouring. Horizontal seal-offs lack this feature and are suitable for level conduit runs. Sealing compounds must be compatible with the hazardous materials present. Epoxy-based compounds offer broad chemical resistance and are suitable for many applications. Silicone-based compounds excel in high-temperature environments. Polyurethane compounds provide flexibility and impact resistance. Always consult the manufacturer's datasheets to ensure compatibility. Proper mixing of sealing compounds is vital for achieving a reliable seal. Two-part epoxy compounds require precise mixing ratios to ensure proper curing and strength. Insufficient mixing can result in a weak, porous seal, while over-mixing can cause premature hardening. Use calibrated mixing equipment and follow the manufacturer's instructions carefully. Pouring sealing compound requires a steady hand and attention to detail. Pour slowly to avoid trapping air bubbles, which can compromise the seal. Fill the seal off completely, ensuring the compound encapsulates all conductors. Use a non-sparking tool to tamp the compound and release any trapped air. Curing time varies depending on the sealing compound and ambient temperature. Epoxy compounds typically require 24 to 72 hours to fully cure. Silicone compounds may cure faster, while polyurethane compounds can take longer. Refer to the manufacturer's instructions for specific curing times. Premature energizing can damage the seal and compromise its effectiveness. Inspect seal-offs regularly for signs of damage or deterioration. Cracks, chips, and corrosion can compromise the seal's integrity. Check for leaks around the seal-off body and conduit connections. Replace damaged seal-offs immediately to maintain safety. Maintenance includes cleaning and resealing seal-offs. Remove any dirt, dust, or debris from the seal-off body. If the sealing compound has deteriorated, remove it carefully and reseal the seal off with fresh compound. Follow the manufacturer's instructions for removal and resealing. Training is essential for safe and effective seal-off installation and maintenance. The electricians and technicians should receive comprehensive training on hazardous location safety, seal-off selection, installation, and maintenance procedures. Training should include hands-on practice and demonstrations to ensure competency. Documentation is crucial for maintaining a record of seal-off installations and maintenance. Keep detailed records of seal-off locations, types, sealing compounds used, and installation dates. Document all inspections, maintenance, and repairs performed on seal-offs. These records can be invaluable for troubleshooting and ensuring compliance. Troubleshooting seal-off problems requires a systematic approach. Start by visually inspecting the seal-off for any signs of damage or deterioration. Check for leaks around the seal-off body and conduit connections. If a leak is detected, determine the source and repair or replace the seal-off as needed. Use a gas detector to verify the seal's integrity and hazardous locations. The detector should be sensitive to the specific gases or vapors present in the area. If gas is detected, investigate the cause and take corrective action. Consider the long-term cost of ownership when selecting seal-offs. While initial cost is a factor, consider the lifespan, maintenance requirements, and potential downtime associated with different seal-off types. Investing in high-quality seal-offs can save money in the long run. Stay informed about the latest seal-off technologies and best practices. Attend industry conferences, read trade publications, and consult with manufacturers to stay up to date. Continuously improve your knowledge and skills to ensure safe and effective seal-off management. Proper planning, combined with the appropriate materials and techniques, is essential to ensure the successful installation of seal-offs in challenging, cold weather environments. The curing time of seal-offs is crucial for their performance. If the seal-off does not cure properly, it may not provide the necessary protection against explosion or fire. Therefore, it is important to take steps to ensure that the seal-offs are kept above freezing for at least 8 hours after they are poured. If working in an area where the temperature is consistently below freezing, it may be necessary to take additional steps to protect the seal-offs. This may include using a heated enclosure or wrapping the seal-offs in insulation. It is also important to monitor the temperature of the seal-offs regularly to ensure that they are not getting too cold. If the seal-offs do freeze, they may need to be replaced. Therefore, it is important to take precautions to prevent them from freezing in the first place. When working with seal-offs in cold weather, it is also important to wear appropriate personal protective equipment, such as gloves and a hat. This will help to protect from the cold and from any potential hazards associated with the seal-off material.